In this activity, we'll be creating a program that utilizes custom error types. Custom error types allow you to easily encapsulate errors into one specific type and can be used to determine what went wrong in your programs. Once you're ready, load up Visual Studio Code and we'll get started. Once Visual Studio Code has loaded, navigate to your Activities directory. We are on Activity 27. So double-click on A27. Once the activity file loads, review the topic and program requirements. Attempt to implement a solution on your own with the video paused. Once completed, resume the video and I will demonstrate my implementation as well as provide insights to the activity topic. Alright, let's get started. As we can see, this topic is on custom error types. The requirements are to modify the program error enum, as we can see right here, in order to make the program compile and run. And we should not modify any other part of the program. The output should display a menu error followed by a math error when running. Our notes indicate that we should use this macro on the enum variants, and we should use the from error type to convert the existing errors into a program error. So in this situation, we have an existing program and we're told that it doesn't compile. In the beginning, we can see that we need to make the program compile. So before I even do anything, I'm just going to browse the code really quickly and then attempt to compile it before making any kind of changes. As we can see, we have a use keyword and we're using an external crate called thiserror, and we are using the error macro within it. We have our program error enumeration, which will be the one that we need to edit. We have a menu error and a math error. These are probably used when something goes wrong with either a menu or math. If we scroll down a little, we can see we have some functions. We have a pick menu function. This one returns either an I32 or a menu error. We have a divide function, which returns either an I32 or a math error. We then have a function named run, and this returns a program error, which is the one that we're supposed to be editing. And finally, we have a main function, which calls the run function with the value of 1 or 2. If we take a look at the run function again, we see that the 1 or 2 determines which functions get ran. So if we get a 1, then the pick menu function will get ran here, and we may possibly get a menu error. And if step is 2, then the divide function gets ran here, and we may possibly get a math error. Since both the menu error and math error are different error types than the program error, we have to make changes to the program error enumeration in order to encapsulate both math and menu errors. I'm going to open up a terminal and attempt to compile the program, and we'll see what errors we can get. And instead of just trying to type in code like we have been before, we're going to use the compiler to give us hints on what we should do next. And then once we get through all the errors, then our program should work and we'll be done with the activity. So I'll open up a terminal by going to Terminal, New Terminal, and we are on Activity 27. So I'm going to do cargo check --bin A27. Remember that cargo check simply checks your code. It doesn't actually build the program. Since we know that there's going to be errors, check will be sufficient and it'll run quicker than doing a cargo run. So we have 9 errors. And when you're going through errors, always make sure you start at the top because some of the subsequent errors may be dependent on the first error. I'm going to scroll to the top and we'll see what we have first. Our first error is an unresolved import error. And then we see we have use of undeclared type or module, this error. So we're using an external crate called this error. And as we can see, the compiler was not able to find it. So this might indicate that we need to add the crate into our configuration file, also known as the cargo.toml file. If we close this and navigate to our cargo.toml file, we can see that there are no dependencies listed. So we'll need to get the dependency for the thiserror crate. If we open up a web browser and then search for the thiserror crate, we'll get the information necessary to paste into here to have the thiserror dependency. So I'll open up a web browser. I'm already at crates.io, so I'll just type in thiserror, and here's the crate listed right here. I'm going to click on the clipboard icon to automatically copy it, and then we can hop back into our dependencies and just paste the dependency. Once you save the file, we can try to check it again and see what errors we get. So if we just run it again, we'll see that it's updating the index, which downloads the crate and makes sure everything's up to date, and then we get our errors again. So now we are down to 4 errors. Previously, we had 9 errors. So as you can see, just changing that one thing got rid of 5 errors in total. So now we have 4 left. So again, we'll start at the top. Here we have the question mark operator could not convert the error to a program error. So we see our code, the run function expected a program error because that's what it has to return. And then on line 47, the pick menu returned a menu error. And it says here that the trait convert from is not implemented for program error. The from right here is a hint that we need to use this from macro that's shown in the notes in order to convert from a menu error into a program error. So let's do that now. I'll go into the program error enumeration and I'll make an error description. So what I did here was create a new error by using this macro, the error macro. And then I created a new variant within the program error enumeration called menu. And this variant will contain associated data, which is the menu error enumeration. When I add the from macro, it's going to automatically allow the compiler to convert from a menu error into a program error. If we did not have this from, then that would not solve our compiler problem because it doesn't know how to convert from a menu error to a program error. But adding this macro automatically will implement the functionality similar to having a derive. One more thing we should do with our program error enumeration is derive the debug and error types similar to the menu error and math error that's listed here. We need to make sure that debug is implemented in order to print it, and error is the special macro that is imported by the crate. So let's derive that now. All right, so now I'm going to do another cargo check and we'll see where we're at. Now we're down to a single error. And as we can see on the run function, we have the divide function, and we can't convert from a math error into a program error. Similar to the menu error, we just need to add a math error. Remember that the program will potentially generate either a menu error or a math error because it calls both of those functions within the run function. So we have to account for both. And we're only accounting for the menu error at the moment. So if we just copy this and then we'll do a math error, let's call it math. We'll have a math error, and this can be from math error. Now we'll compile this and see what we get. Now we have no more compiler errors, so we can run the program and see if it works properly. We do cargo run --bin A27. Here we see we have a menu error first, followed by a math error. And according to the requirements, the output should display a menu error followed by a math error when we run the program. So we have now completed this activity. In general, when creating custom errors for your programs, it is a good idea to use explicit enumerations, such as the one created in this activity. Using explicit error enumerations allows people using your code, including yourself, to easily match on a specific type of error and handle it appropriately. For example, a menu error might not be that big of a deal, and you could just redisplay the existing menu if we happen to encounter a menu error. However, a math error could be more severe, since the calculation cannot be completed and there is no recoverable action to take except to abort the function and then possibly display an appropriate user message. Without explicit error enumerations such as these, it would not be reasonable to determine what actually went wrong within your programs, so you wouldn't be able to display an appropriate error for your user. This is why in this activity, we have multiple different error types associated with each function. That way, if someone wants to use this code to create a program built off this functionality, then they would know what errors happen in case those functions fail to complete. This concludes the activity on custom errors. I'll see you in the next presentation.